Our today's lesson is solving systems of linear and quadratic equations. To solve any system of equations, you can do the following. One, you can graph both equations in the same plane and locate the points of intersection. Or two, you can solve the equations algebraically. And by algebraically, that means either substitution or elimination. All right, for example, solve the following system by graphing. Now here we have a quadratic equation. You can tell because x is raised to the second power, y equals x squared minus 2, and y equals negative 2. I'm going to start off with the linear. Y equals negative 2 we know is a horizontal line. So what we're going to do is going to count down 1, 2. And what you want to do is make a point. Make a line here. This is y equals negative 2. So it's going to look like this. And in order to graph this one, we know that y equals x squared is going to be that u parabola. But now we're going to have to go down 2. So it's going to start here. And if you evaluate 1, you're going to get negative 1. Which means the opposite side, you evaluate negative 1, is going to give you the same result. And if I plug in 2, I'm going to get 2. Positive 2 on the other side. So our parabola is going to look like this. And the point of intersection is where the both graphs touch. So if you look at the parabola and you look at this line, it touches at 0, negative 2. So that's going to be the solution to this system of equation is 0, negative 2, because that's the only common point of intersection. But let's say you didn't have the graph. How would you do it algebraically? Well, it says y equals x squared minus 2 and y equals negative 2. And what you can do is, since y is the same number, you're going to set both expressions equal to each other. That's what you can do. And solve for x. So what I can do is I'm going to isolate x squared so I can add 2 to both sides. So I'm left with x squared equals, well, negative 2 plus 2 are opposites. That's going to be 0. And we know the square root of 0 is 0. So x has to be 0. And you can plug this value into either equation. You're going to get the same thing. Let's say I plug it into here. I get 0 squared minus 2. That forces y to equal negative 2. Thus we have 0, negative 2. If you plug into the other one, you would have got the same thing. Y equals negative 2, it tells you. So automatically, x is 0, y is negative 2. So that's the point of intersection if you do it algebraically. All right, solve the following system by graphing. So we have a similar case here where we have a quadratic and we have a linear function there. Y equals 4x. Well, the slope's going to be 4, but the y-intercept is 0. So you start here. And you can count over 1 and then go up 4. 1, 2, 3, 4. And so on. You can count over 1 and then count up 1, 2, 3, 4. Or I can go to the left 1 and count down 1, 2, 3, 4. 1, 2, 3, 4. And you're going to connect those. And that's what that looks like. And if you're going to graph the other one, so I'm going to use another color here, let's say the quadratic. In this case, you're going to have to move this quadratic to the right 3 spaces. So I'm going to go over to the right 1, 2, 3. But I don't go up or down. And you're going to make your points. So if this is 1, 2, if x is 2, I'm going to get 1. And if x is 4, I still get 1 because it's the symmetric law. If x is 1, I should get 4. 1, 2, 3, 4. All right, so it's going to look something like this. And if you notice, this is the point of intersection. All you're looking for is the point of intersection where the two graphs meet. So we know this intersection, if you go over 1 and come up 4, is the point of intersection. If you don't have the graph, what you're going to do this algebraically. And again, since both equations are set, y is equal to a different expression and y is the same number, you can set those expressions equal to each other. So I can do this. So I can put x minus 3 to the second power equals 4x. Then you want to expand that. This is going to be x squared minus 6x plus 9. And you set that equal to 4x. And if I were to subtract 4x to both sides, I get x squared minus 10x plus 9 equals 0. And you can factor that. You can say what two numbers multiply to 9 but have a sum of negative 10. And if you think hard enough, you'll see that's negative 9 and negative 1. If you multiply those two together, you get positive 9. At negative 9 plus negative 1 is negative 10. So what that tells us is that you get x minus 9 equals 0. You get x minus 1 equals 0. So that tells us that x has to equal 9, or it can equal 1. And you can plug it into either expression. 4x is the easiest, so if x is 1, we get y equals 4x, correct? So if y is 1, x is 1, y has to equal 4 times 1, which means y has to be 4. So we know it has to be 1, 4. Okay, solve the following system by graphing. All right, so we have this quadratic here. And I notice it's a negative coefficient in the leading coefficient. So we know it's going to have this shape here. And we have y equals negative x plus 2. So let's graph the linear first. So our y-intercept is 2. And we know that our slope is negative 1. So I can go to the right 1 and go down 1. To the right 1, down 1. And so on. Or I can go to the left 1 and up 1. will be our line. All right. And if you were to graph the other one, if you get the vertex point, you want to find the highest point on this where it starts. That's going to be negative b over 2a. We know that b is negative 4. So you have minus 4 over 2, and a is negative 2. If you simplify that, you're going to wind up with a negative 1. So our point's going to be negative 1. If you evaluate that back into this expression, you're going to get y equals 3 when x is negative 1. So let's graph that. They're going to go to the left 1 and go up 1, 2, 3. All right, and then if you plot to the left and right, let's say x is 0, then you're going to get 1 here. And since this is like the symmetry here, the line of symmetry, it's going to be equally distant, so you're going to have another point there. And x is 3, you're going to get negative 5. So 1, 2, 3, 4, 5. 1, you're going to get 1, 2, 3, 4, 5. So you're going to get this graph here. But now notice that this is a common point of intersection. And that point is negative 1, 3. Because that's where it crosses. This is also called a tangent because this line just touches that one point on this parabola. So negative 1, 3. If you were to solve it algebraically, you would set these two expressions equal to each other because y is the same number. And then you just simplify that. It'd be negative 2x squared minus 3x plus negative 1 equals 0. And what you could do, if you want to get rid of the negatives, you can multiply both sides by negative 1, as long as you do it to both sides. So you can have a positive, deal with positive values here. And then you want to factor this. And if you factor it correctly, you're going to get 2x plus 1 times x plus 1. And you set it equal to 0. So you set both expressions equal to 0. I get x equals negative 1/2. And I get x equals negative 1. If I plug in x equals negative 1/2, I'm going to get y equals 3. And we know that matches with the graph. You're not going to accept the other solution. That's what we call an extraneous solution. So this would be negative 1, 3. All right, this concludes our lesson for today.